Hello friends, creating oxygen is crucial for prolonged space missions. In this video we will study how scientists generate oxygen in this inhospitable environment. Living on the same planet that we evolved on, it can be easy to take things for granted. We have an abundance of fuel and fresh water, plants and animals for food, and an atmosphere with plenty of oxygen. Yet we also have plans to send people off-world. In the coming decades, humans will set out to explore our solar system in greater detail than ever before. There is plan to establish a base on the moon through NASA's Artemis mission, and even send the first people to Mars. There is oxygen in space. No, there is no oxygen in space. Therefore, scientists and engineers must figure out how to best provide crucial resources to the people who first set foot on these foreign worlds. The production and recycling of fuels central to human life support systems will be key, as resupply missions or resource extraction might not be possible. A common device used in the production of oxygen and hydrogen in space is the water electrolyzer. It uses electricity to split water into oxygen and hydrogen, thereby converting electric energy into chemical energy that can be used as fuel or as an oxygen supply. However, in a new study, researchers investigated the viability of using a photoelectrochemical device as the primary system for creating hydrogen and fuel in space. A PEC device operates as an artificial photosynthesis device, integrating in a similar way to natural photosynthesis the processes of light absorption, charge separation and catalysis, says Katarina Brinkert of the University of Warwick, a co-author of the study. The new devices may save weight and size when sending payloads into orbit from Earth, potentially providing a more energy-efficient means of creating oxygen and hydrogen than previous systems, which relied on water electrolysis. Moreover, they could combine the production of oxygen with the removal of carbon dioxide and the production of fuels, a great advantage, says Brinkert. We have shown that when they are combined with solar concentrators, they actually provide a viable possibility for space applications. Yet, there are other ways to produce resources in foreign space environments. One such device is the MOXIE, an oxygen-producing module on one of the Martian rovers. MOXIE converts Martian atmospheric carbon dioxide directly into oxygen using an electrolyzer, though its yields of oxygen have been relatively low. And life support systems don't stop at creating oxygen. On top of producing breathable air and creating fuel, journeys to Mars will also require an efficient wastewater recycling system and a way to source local materials for equipment repair. We must also consider the conditions through which human psychology can survive and thrive, outside of the conditions that are right for our physiological survival alone. NASA is already conducting Mars simulations to see how people behave in confined spaces and farther away from help than anyone has ever been. When we've finally developed technology that serves our logistical, physical, and psychological needs, we'll be that much closer to making our exploration of other worlds a reality. Thanks for watching the video.